For number 5, keeping our x from being by itself here is that 2.3. So it is positive. So to get rid of that positive 2.3, we need to subtract 2.3. Negative 7 minus 2.3 would be negative 9.3. Be careful, x is on the right-hand side. If you want to flip-flop that, keep the point pointing at your x, except then that makes the other side not x. So again, if I say this is negative 9, negative 9.1, negative 9.2, then our last one would be negative 9.3. Solid dot because of the or equal to, x is less than or equal to that, so my shading does come to then the left. For number 6, x plus 4 is less than 3, plus 4 keeping x from being by itself, so I'll do the inverse, which is to subtract 4. 3 minus 4 is negative 1. Open dot, no or equal to, less than, shading to the left. And our last one, keeping our variable a from being by itself is this plus 2/3. I'll do the inverse, which would be to subtract 2/3. Again, a little mental math off to the side. Common denominator between 4 and 3 would be 12. 4 goes into 12 3 times, so 3 times 3, 9. 3 goes into 12 4 times, 4 times 2, 8. 9 minus 8 would be 1/12. Again, our variables on the right-hand side, I'm perfectly fine with that, but if you want it on the left, mouth opening towards that a, so I would say that a is greater than or equal to 1/12. Why not go in 12ths? 2/12 would be 1/6. Okay. Solid dot at 1/12, because we do have an or equal to, it is greater than or equal to, so then my shading will come to the right. All of those, to isolate our variable, we had to subtract, subtract, subtract. So all of these use the subtraction property of inequalities. Again, they're the exact same properties we saw when we used equations, except now instead of equality, they're of inequalities. And also still using those inverse operations. So to apply our inequalities, it asks to write and solve an inequality that represents the value of x. So we're told that the perimeter is less than 25 feet. So, less than, we can insert our inequality symbol, and the perimeter has to be less than that 25 feet. Well, how do you get the perimeter of a figure? Exactly, add up all of those sides. So if I add up the sides, doesn't matter what order, x plus 5 plus 7 plus our last side, which is also 5, that has to stay less than 25. Well, combine these like terms here. 5 plus 7, 12, plus 5, 17. To isolate that x, we need to get rid of that plus 17, so I'll do the inverse, which is to subtract the 17. So then I have 25 minus 17, giving me x is less than 8, and label that 8 feet. So in order to keep that perimeter less than 25 feet, that missing side x would have to be less than 8 feet. Make sure word problems, just like with equations, we have to label those answers, do the same exact thing with our inequalities as well. And our last problem there, another application problem. We raised $225 for a charity. Our goal is to raise at least $600. Write and solve an inequality that represents the amount of money we need to raise to reach your goal. So we don't know how much money, more money we need. We have $225. we want to raise at least $600. At least. That means that's the smallest amount. So we want to be greater than or equal to that $600. How much more money do we need to raise? Well, we need more, so we would have to add something on to that. Well, there's our addition problem. Therefore, we will solve. So to get our x by itself, subtract that $225 that we already have from the 600 that we want to be at. Subtracting 225 from 600, we're left with 375. Make sure we label that dollars. So in order to raise that goal of 600, we need to raise at least 375 more dollars. So again, we would insert that inequality symbol. Be careful, at least. That means that $600 is the smallest, so anything bigger than that. And notice that point is pointing at the 600. This is less than. What we want needs to be bigger than that. So again, exactly like we did with solving equations, to isolate our variable. To get rid of addition, use its inverse, which is to subtract. If there's subtraction, use its inverse, which would be adding.